Hi guys, welcome to Geek Coding Academy. Today we'll see Java Collection Framework chapter 6.9, that is concurrent collections. So let's see. So in our previous videos we talk about all these concepts. So if you have not watched this video, please watch that video prior to this. So today we'll talk on concurrent collection. So what do you mean by concurrent collection? So for collection we already saw that will be like a set of classes will be there that will be used to manage our data. But what particularly a concurrent collections? So concurrent collection is nothing but some collections is there. Sorry, some set of classes which will be available in java.util.concurrent packages. So why these classes? These classes actually they are um, using the same collection classes only, but few modification will be done on these classes. Why these classes are used is when we are using a multi-threaded environment, suppose. Okay. So what is multi-threading? Means at a time more than one thread as acting. That means like when I go into a thread concept, I'll explain more detail. Now you can think of like a multi-threaded environment, or means multi-threading means more than one process acting on the same collection of collections or same data. More than one thread means each thread means it's a process. Suppose like I have a collection and one thread is accessing that collection means reading the data, and another thread is trying to write a data to that collection. So this is a multi-threading. So once we are doing any this multi-threading operation on a collection, on any collection, there will be chances of deadlock, or there will be chances of some bottlenecks or inconsistent states. Suppose like suppose like some one of the thread is trying to put a data to a collection, and another thread is trying to access that, but so the accessing thread has to wait until these saving thread or putting data thread should complete, then only this accessing thread will get complete data, right? Otherwise there will be an inconsistent states. So in order to avoid all these problems, a Java team has provided us these concurrent collections packages. So what are the classes or what are the implementation available on these concurrent collections? Let's see. So we have a concurrent hash map. So hash map we already saw in our previous videos. This concurrent hash map is similar to hash map, but it is a thread safe, and it will support these multi-threading operations in a safer way that it will not cause any bottlenecks. Okay. And another one is a copy on write array list. This is a safer version of array list, means thread safe version of array list. Array set. This is a thread safe version of array set. And linked queue. It's a thread safe concurrent linked queue. And concurrent skip list map is a map implementations only, but it is a thread safe, and that uses an algorithm called skip list. Based on that, we given the name as a concurrent skip list map. And concurrent skip list set, that is a set version of this skip list algorithm. And blocking queue. So what do you mean by blocking queue? In queue we already saw. Queue means like it's in a FIFO order, like first in and first out. It just like it you may consider like a going or taking a movie tickets queue. So where the first person will comes and he will get the ticket, right? Like first in first out operations. That's what queue. This blocking queue means this is actually an interface which come under this queue, where the some of the sub like child classes of these will be like there are several like priority blocking queue or etc etc. That means like if two threads were acting on, like one thread will wait, or one thread will be completely it will be blocked until another thread complete its execution. So that's the reason we gave it as a name it as a blocking queue. And link transfer queue. Okay. This is also another type thread safe type of queue. So let's see one by one, guys, so that you'll understand more. What is a concurrent hash map? Okay, it's a thread safe version of hash map. So unlike hash map, if you use the normal hash map, which is not safe for concurrent use. Suppose like that I created in a collection, which is a hash map type of collection, and multiple threads are acting on it. It's not safe. So I have to what are the option I can have is I just has to make the class as synchronized, or I just need to handle. So instead of that, I could have used the concurrent hash map, so such that it will allows multiple thread to read and write without the need of any external synchronization. So what do you mean by the synchronization? Now to make a class itself as a synchronized, or how to make a thread safe classes and everything I'll talk about in thread chapter. Now we'll talk about on only concentrate on collections. So in collection, we have one more concept called concurrent collections, where we have this concurrent hash map. If you use this, it will be thread safe. Okay, it will allows multiple threads to both read and write operations and without need of any external synchronization. What is the internal implementation? How it works is it uses a segment based locking mechanism. Okay, where the map is completely divided into multiple segments and each segment is locked independently. Okay, so this reduces the contention with the multiple threads try to access the map. Okay, there was a locking mechanism happening, like one thread is trying to access, it will lock other threads until this thread finishes its operations. Okay, let's see the implementation. So I have created here a concurrent hash map object, and I put here like using put method I have added data to it, and another we have a certain methods only for this concurrent hash map, like put if absent. That means like it will put the data if the data is not already present and it will wait. And similarly we have a compute if absent. Same way, like these are all some of the specialized methods we can get using a concurrent hash maps. Okay, but some of the changes is like we does not allow null keys or null values that we know, and operation like put if absent, replace, compute if absent, like make it easy to perform atomic operations. These are all called atomic operations. Like we'll talk more on this, and it lock free reads for better performance. Okay, let's say in another type is copy on write array list. This copy on write array list will be thread safe variant of array list. Okay, the list is safe on concurrent reading by multiple threads. Okay, while any modification, suppose like some of the threads for adding or updating or removing some data, what it will do is it will create a new copy itself of the being array should be created. New copy it will create, and it will serve that to other threads which were accessing the data from it. Okay, so this was the idea, but the main use case will be like when we need to use this copy on write array list only in the cases where um, the read operation is more compared to a write operations. Okay, because in write operation if any modification happens, it will create a new copy, and the old copy it will destroy. So it takes time and it can be expensive. So we need to use this in such a cases there where like our read will be more compared to write. So let's see an example. I created this copy and write array list, and I've added these two data 10 and 20. So that's it. Like concurrent modification will happen, like two threads at a time can able to act read. So it will support that, and it will ensure data consistency during iterations as iterator works on a snapshot of the list. So there will be like data consistency will be there. Okay, let's see another type, copy on write array list. This sorry array set, it's like a set counterpart of array list. Similarly, like it implementing the set interface only, but it ensures no duplicate. Like that's the main features of set. Set there will be no duplicates, and it's also create a new copy underlying array on every modifications. So this is syntax. I created an object of copy on write array list where I added these two values a and b. Let's see another type, concurrent linked queue. So okay, an implementation of a non-blocking queue that uses a lock-free operation for a thread-safe access. Okay, like we have in a blocking queue and non-blocking queue. Like this concurrent linked queue is a non-blocking queue. Non-blocking queue means like when we are trying to add a data, it will not block the like suppose we want to add a data and retrieve a data. So for what it will do is it will block the retrieving data thread and allow the um, adding data thread. Then it will allow the reading thread. Like that is what we call as in a blocking queue, but it's a non-blocking queue. This concurrent linked queue, and it uses a lock-free operations. Okay, for a thread safe access, and it is unbounded queue and follows a FIFO order. I already told like queue is just like a first in and first out. So it will be ideal for producer consumer problems where one or more thread um, uh, queue the elements and other thread is dequeuing elements. Suppose like a producer and consumer we have some operations. Like producer is to add a data into the list. The consumer is to retrieve data from the queue. So the queue and dequeue operation we can able to do without any bottlenecks or any data inconsistency. So this is a syntax where concurrent linked queue add these two values, item 1 and item 2. So these are a similar guys, like this concurrent operations is similar to like how we do in collection implementations, like hash map, the concurrent hash map. Both are work similar, but in concurrent it will be thread safe. You may consider like that in brief. So because I can't go deeper now because you don't know the concept of threads and everything. Like once I finish that thread concept, then only I can able to explain all this more deeply. This is just for an overview. Let's say in a concurrent skip list map. Like it's a thread safe, scalable implementation of a sorted map. Okay, and it's based on a skip list data structure that I already told. Like skip, what is skip list data structure? I'll talk about that in our data structure and algorithm classes. And it's provide a natural ordering of its elements. Okay, it's suitable for a scenario where the map need to be sorted and also it should be thread safe operations or accessed concurrently. Then we can go with a concurrent skip list map. So this is an example where I created a concurrent skip list map and I added these two values A and B with 10 and 10. Okay, what do you mean by like we'll see concurrent skip list set? It is a set counterpart of concurrent skip list map only. Like it's sorted, thread safe. It is backed by concurrent skip list map. Okay, so when we need any thread safe sorted set, we can go with this. This is an example where I created a concurrent skip list set. Add these two values A and B. Blocking queue. Okay, I'll explain you this. A specialized type of queue. This blocking queue is actually an interface. It's come under queue. Like it's a specialized type of queue that support operations that block the calling thread when queue is empty. Suppose there is no data in our collection, operation that retrieves element will wait until an element becomes available. Suppose like we have two threads. One thread is accessing data and another thread is writing data. So if my collection is an empty, so the accessing thread will wait until the collection thread puts some data to it. That's what it's about blocking queue. Similarly, when a queue is full, like insert operation will wait until the space become available. Suppose when we creating this queue, we provide type of some amount of data size of the collection. Suppose it has been filled, the writing thread will wait until a space will be available. So what are the implementation for these interfaces? Array blocking queue. That means a fixed size blocking queue backed by array. Linked blocking queue means it's optionally bounded blocking queue based on linked nodes. Priority blocking queue. It's unbounded blocking queue that orders element based on their natural order and or any comparator given by an user. Delay queue, a specialized queue where elements can only be retrieved after a delay is expired. And guys, I am not going deeply on all this implementation because these are all legacy. We have other ways to achieve all these. These are all legacy classes. So just for your information and just want to know what are the classes available in this concurrent queue, we can go for this. So let's see an example of array blocking queue. I created an array blocking queue of size of 10. I'm creating array queue dot put of 1. So it will check if the array blocking queue size is available or not. Suppose like I created with 10 size. If it's completely filled, then the put method will wait until it becomes empty or until one space will be available. So that's the reason. Like it will block if queue is full. The put operation completely block if queue is full. Similarly, take is the operation to retrieve. So it will block if the queue is empty. So empty, there is nothing to take. So that this blocking queue will block that thread and it will allow the right thread. Once right thread will process the data, then it will allow the accessing take, that is take method to access the data. This is what it is. And we'll see in the next implementation, link transfer queue. It's a specialized form of linked blocking queue that support producer waiting for a consumers to receive elements. It is optimized for transfer operation where producer and consumer threads coordinate to exchange data directly. Suppose like producer means something you think like some I have one function that is giving us the data and sorry, producer means I have one function that is giving us some data and consumers are something that was taking data from us. So in middle, we have one collection that if you use this link transfer queue, what it will do is it will link this both producer and consumer. Like a consumer is waiting until a producer provided data, and once data is provided, directly consumer consumes that. Okay. So this will be ideal when both producer and consumer have sensitive data and to whether data is being actively passed between them. Okay. Okay. So this is what about link transfer queue. Like it directly transfer data from producer to consumer. Okay. So high throughput due to optimized handoff between threads, and it supports transfer methods that block until elements are consumed. Okay. That means like to add data to this link transfer queue, there is a method called transfer where we pass the data. If you do this data, it will wait for the consumer. It will not simply add into the collection. It will wait for a consumer thread. Once consumer thread, it will add and immediately pass on to a consumer. And this consumer thread also, suppose if consumer thread will be available at the beginning, it will wait for a producer thread to give the data. So it will be like some sensitive data, like we can able to use this type of concurrent collection interface collection class that is linked transfer queue. So this all about brief overview of concurrent collections. Let's see some of the key points. We have a locking. So many of the collections have above avoid the use of global locks. That locking means like one thread is trying to access and one thread is trying to put the data. So this other thread, if it's dependent on another thread, both will um, want the same type of data, but both will not get at a time. So these two threads will get into a deadlock state. So if you go into a deadlock state, none of the thread will be released and the program will be hang up. So it will not go. Like if you use the concurrent collections, like global locks will not be there. And using techniques called lock stripping, if you use concurrent hash map, it will strip the lock. That are all techniques and algorithms I will explain. And performance wise, in a multi-threaded environment, using any concurrent collection can significantly improve performance over traditional synchronized collection. Like traditionally, how we are synchronizing like one thread at a time. Instead of that, we could have used these concurrent collections. So it will be performance will be significantly improved. Okay. Thread safety. These collection handle most of the synchronization. Most of the synchronization these collections will do, and it make developer life easy. Okay, when we are working with the concurrent environments, like what are the concurrent environments? Suppose like I want to do a payment gateway or something stuff like that, or any buying a purchase, some real-time operations I'm talking about. So where the payment should be transferred only after it has deducted from the buyer's bank account, and so much of banking operation are concurrent, like it will be like one to related with each other. And also independent operation can't be done until some other operation should be completed first. The time and all we could have used. I'll create one real-time application, guys, like after this, so that we'll implement all these concepts. So practically we'll get an a hands-on. So learning programming is only happen when we do our hands dirty. Otherwise, we can't able to achieve completely. Like yeah, that we'll see. So by choosing these appropriate concurrent collection, it's like based on specific needs. Again, it's based on requirement. If suppose I'm building an application which required only single threaded, if I'm using this concurrent collection, it's of no use, right? So it's all based on specific needs or requirements, whether sorted order, FIFO, blocking queue, etc. We can also ensure that optimal performance and thread safety in concurrent applications we can able to do. So this all about today's session, guys. Like I hope you guys enjoyed the today's lecture. If you guys have learned at least something from out of this today's lecture, please like our video, please subscribe to my channel, and please share this video to your friends and family, friends and colleagues. So I'll meet you guys in my next lecture with more advanced topics. So till then, keep watching, keep learning. Thank you. Bye. Have a nice day.